Okay, hi everybody. Morning. My name is Chuck. Welcome to my session. Uh, First of all, thank you, for taking time out from your from your work, to join this learning day or this session, and in particular, that you have come and joined my session. I feel very honored. So for the next, I wouldn't say an hour, but probably about half an hour to about 35 minutes, I'll share some of the habits of effective software developer. Predominantly, these habits, quote unquote, is actually from some of the things that I have done and some of the things that I have observed from my buddies, from my colleagues, buddies and stuff like that. Of course, this the title of this presentation is actually borrowed, quote unquote, from Stephen Covey. So apologies to him. And also, effective is, if you notice, is an asterisk there. So is your mileage may vary. And if you like to follow this, like to have a deck, you can get the deck from this link. Bit.ly 7_effective habits, or also just scan this QR code. Okay, so a little bit about myself. What is this chief of StackUp? In ISS, one of the learning track, one of the curriculum is StackUp, and what we do is we teach the more leading edge or more leading edge technologies like cloud, like Ansible, Terraform, Kubernetes, full stack development and stuff like that. We also work with a startup, help them with their applications. Sometimes we help them to do some prototypes and things like that. Okay, so that's what we do. Prior to joining ISS as a lecturer, my experience is I've got quite a varied experience. I've been a product manager for the Java runtime and also for some application servers. I was part of the at Sun. I was working for Sun Microsystems, and also part of the technology evangelism team for Sun Microsystems. What as a technology evangelist, or I suppose now they call it a developer advocate, what we do is that we build demos, we work with our partners, to help them to bring applications, onto the Sun platform, onto Java. I was also part of the ISV support team. ISV is an independent software vendor. Oracle and Sun has partners, right? And these people are develop software, so we need to help them, to do things like transfer of information, teach them how to use our products, teach them how to program, help them with debugging and stuff. And prior to that, I was also a support engineer, predominantly installing Linux systems, doing hardware. Back in the days where dinosaurs still roam the earth, we don't have the luxury of going to your browser and clicking and deploying a server. We actually have to physically unpack the server, carry them from the truck, put in the cable and stuff like that. So I was a support engineer. I was installing hard disks, installing Linux systems and stuff like that. All my life I've been actually a developer. I'm still a developer now. I started programming by accident in 1981, and then I liked it so much that I took it up as a career by choice in 1990. I enrolled. So when I started programming in 1981, I love it. So I enrolled in computer science course. So I decided that I wanted to enroll, do computer science. I wanted to do this, to learn this new thing about this thing called computer. At that time, it was like a desktop computer, Apple II at that time, right? And also, yeah. So I wanted to do computer. So I enrolled in RMIT in Melbourne, Australia. Victoria, Australia, and I told my parents about it, that I wanted to do computer science, and they had no idea what computer science is. At that time they thought that I wanted to do electronics. At that time, if you remember, you may not remember, you may not have been born, but in the early 80s and in the mid 80s, there was this big surge in electronics, and there were a lot of people getting electronics, and they thought I wanted to do that. But then I told them I wanted to do computer science, and they didn't know what computer science was. So anyway, I prevailed, and I did computer science at RMIT. I've got some online presence. I've got GitHub.com. Some of my work are there. Some of them are are private because I work with people, so I cannot share those. And I also got a YouTube channel which I don't actively promote. I basically is for my testing, for my for my own learning, and I'll explain some of this thinking in my session. So 1981, this is my first foray into computers, and this is the thing that got me started. At that time, I was actually staying with my uncle, and he bought. He's an electronic engineer, or electrical/electronic engineer, and he bought he ordered a board from US. And this is the board. The board is called OSI, Ohio Scientific Instrument Superboard 2. So this thing is a 2. It's not 11. It's a 2. With reference, because at that time everybody is trying to copy like Apple II, right? And so this is literally how the thing looks like. So it doesn't come with a box. He built a box around it, a wooden crate, and just put this little thing in there and hook up he got a small, 12-inch, like small 12-inch black and white TV monitor, and he hooked it up to it. And then once he turned it on, the thing stays on, right? And so after that, it was sort of left on one side because he didn't do anything with it anymore. And in those days, if you buy a computer, the really good thing about it is that they actually come with manuals, software manuals that teach you how to program. And one of those manuals is actually BASIC, okay, BASIC. So one afternoon, I took up the BASIC book. So I was playing around with it. I was looking at it, right? So I turned it on and I took out the book, and then I opened the book. And the first program that I wrote wasn't "Hello World." It was 10 input. What is your name, comma, name, question mark, $, and then 20 print hello, comma, name, $. I still remember it vividly. So that's how I started my first program. Okay, so I typed it out, I ran, I thought, hey, I kind of like this. So I began to play around with it. So at that time, just around that time, there were a lot in secondary schools in Singapore, there were a lot of computer clubs springing up. So I joined one of these computer clubs to learn more. So so my first foray into computer, it was still fun and games, right? And the thing that really made me interested in taking up programming as a career is this game. So this game, by today's standard, is not 3D. It doesn't shoot or kill anybody. And the sound is the sound is like monochrome, right? But this was the game that actually made me interested in programming. I'm not sure how many of you remember have ever played this game. If you do get a chance, you should go and try playing it, right? Of course, do keep it in mind that it is very primitive by today's standard. So this game is called Load Runner, okay? And the idea is this guy. So there was this. Actually, I don't see the bad guys here, but so I think probably these are the bad guys. So these guys are going to come here, and then the way you avoid them is to actually dig holes on the left or on the right. So when you dig a hole, the guy will fall in, and then you can walk over it. You're supposed to collect all these boxes. And the thing that actually got me interested was the graphics for this guy that's moving, this hero is moving, is the smoothest graphics I've ever seen. Okay. At that time, I got into Apple II programming, and I was actually doing a little bit of graphics, vector graphics. And this was the smoothest thing that I've ever seen. And I told myself I wanted to do this. Okay. Of course, back in 1982, writing games wasn't a career option. So I took the normal. I did computer science, and I took the normal route. I become like a software developer. Like everybody else. So then fast forward to then I took a job, and then then I started programming, right? So the first version of this presentation that I gave is way back in 2006, 2007. This was back in the days when I was still working for Sun as a technology evangelist. So I put down some of my thoughts. One of my colleagues said, maybe we should, since you're programming for so long, why don't you, put down some of your thoughts and share some of your insights quote unquote, right? So I thought, oh, yeah, okay, maybe I can do this. I'm not sure how helpful they are, but let me put this down. So that's the first version. You can still actually find this online. The really funny thing is this, I actually found this copy online. I was just Googling through the other day and I found this copy online, and it's actually behind a paywall. I only get the first screen, right? So, I don't even have the original source anymore. Okay, so of course, some of the habits, some 7 habits, some of it has changed slightly from than what I want to do, that what I'm going to talk about today. But I believe that they are still effective. So again, these habits are some of the things that I do, and also I observe some of the things that my colleague do, and some of the things that I've adopted. Okay, so let's start with the first habit. So here's a picture. What do you think is the first habit? Okay, so what do you think is the first habit? Okay, so the first habit is understand the problem. Gistra say computer science is no more about computers than astronomy is about telescope. Okay, so programming is really about problem solving. So whenever whenever you study computer science, they will teach you, stuff like algorithms, like data structures. It's really about problem solving. Writing the program is the last part of your programming journey. So you have to solve the problem first, and the program is just an expression of your solution. So focus on the problem. So what are the issues that you're trying to tackle, for example, right? So one of the things that I like to give my class is, right, tell me how, so we all know how to shuffle a card, randomness, right? How shuffle a card. But so they always ask them, tell me how would you go about explaining, shuffling a deck of cards to like a 5-year-old or a 7-year-old, step by step, right? So, and then they'll say, just move the card around, but you cannot just say move the card around, right? Because you need to describe it step by step. Okay, so focus. So what are the problems? What are the issues? A lot of times, sometimes, especially when you start getting into programming, when you're starting off, sometimes the problem is really, really difficult to imagine, right? So generally, what I do is this: I create a boundary around my solution. How much is it that I want to tackle? Okay, how much is it that I want to tackle? So once you have a boundary around your program, how much is it that you want to tackle, the things that you want to solve and the things that you do not want to solve, then it helps clarify the problem. It brings the problem down to something manageable. And also having a boundary, creating a boundary for your problem helps you to how should I say, helps you to voice, or helps you to say out exactly what is it that you're trying to solve, right? So once you have a boundary, then you can work either inside the box or outside the box. A lot of times, when I talk to people, they say, you should think outside the box. Sometimes if you don't even have a box, if you don't even have a boundary, how is there there's no way that you can think outside the box. Okay, so have a boundary. A lot of times, right, when you see, when you see like people say, oh, I want to solve world hunger problem, like that's a really, really big problem, right? And you have to understand that, the world hunger problem or world peace problem is not one solution for the whole problem, because every one of those hunger problem in every different country or every different region is caused by a different problem. Some of them is famine, whether some of them is war, right? Some of them is a lot of different region. So by actually creating a boundary around your problem, like say I want to tackle this area because it is famine and that's why it's causing hunger, then you are creating, then you have just defined your problem, and then you can solve it, right? Either by creating more irrigation or whatever. Okay. The other thing about programming is, learn programming, not programming languages. And this is very, very important. A lot of times, when you attend, like you look at YouTube videos, learn how to write a node application, in 30 minutes, whatever. What they're teaching you is, right, they're teaching you a pattern of solving a problem. If you do not know programming and you learn that, then when the problem changes, you are not able to change. You're not able to adapt the problem. So you need to know programming, not programming languages. Now, this is easier said than done, because it's very easy to learn something. Just go to YouTube and learn to write one web application, right? Or learn a specific machine learning problem, by creating a linear model, and then either do regression or do classification on it. But try to understand what is the underlying problem, right? Again, if you look at, for example, like I don't know whether you watch documentary, but if you watch documentary or some of this documentary on YouTube, right, and you see sushi chef, right, when you hear them, when they're interviewed, you hear them say, right, I spent like 3-4 years, learning to clean the fish, select the fish, right, fillet the fish, right. So those are the things that helps you with your learning. So those are like their programming stuff, right? The final part, where the chef, just cut a few fishes, put some wasabi on it and serve it to you. That's the last part. Okay. Okay. So second problem, second habit. What's the second habit? Okay. So the second habit is use the correct tool. Abraham Maslow said, I suppose it is tempting if the only tool you have is a hammer, is to treat everything as if it were a nail. To paraphrase, what he's saying is this: if you only have a hammer, then every problem you see will be a nail, right? So what you need to do is that you need to keep your tools fresh. So as programmers, we have two types of tools. One that we have it mentally in our head, things like our data structures, our algorithm, our design patterns, right? Another one is the tools that help us to develop and to deploy application. The tools that you have, the data structures that we keep our head, right, for mentally constructing or solving the problem, things like data structure, algorithm, and data and design patterns, and you need to keep this fresh. It's very, very important to actually know them. If you do not know, take a course, right? If you do know them, keep them fresh by reading lighter versions, by constantly refreshing yourself by reading lighter versions of this, by reading blogs, or medium article, etc. Use a variety of tools, especially during development. Use a variety of tools. So the tools can be IDE or your editor, right? The thing about tools is that you need to understand is that tools can actually help or hinder us, right? And very often we are not even aware that certain tools becomes a hindrance. For example, code completion. In most editor today is a modern day. So when we use editor, we expect the editor to help us with code completion, and it's a double-edged sword. The reason is because the code completion will tell you what to use, will tell you what API to use. And personally, I find that although it's very helpful, personally, I find that this can be quite limiting if you are learning, because by suggesting which API you use, then a lot of times I find myself, I don't bother to actually go and look up other APIs, right? So it's a double-edged sword. And today with AI building into most of these IDEs, right? This prompting features is getting more and more powerful. So I'm going to suggest this, maybe a little bit controversial. If possible, try not to use code completion, or if you have to use code completion, try to explore all the API options. Okay. Also, another thing is this: you need to understand what tools you're using and why you're using them, especially with regards to design patterns. Design patterns are these things that programmers like to have where given a solution, there is a group of sort of like there is a blueprint that sort of fit this solution. For example, if you want to write for like a web application, there is this really nice design pattern called MVC, right? Model View Controller that sort of fit this paradigm, and it really helps, in structuring the code. But sometimes I find that I've seen people, what they do is this: they are so afraid to modify the design pattern to fit their problem. They just use the pattern wholesale without ever modifying it, and this is really bad. Secondly, they try to fit everything that they do into a particular pattern, right? This should not be the case. Your problem should dictate what tools you use or what patterns you use, not the other way around. In other words, you don't take a pattern and say that this is the solution for the problem. You have to study the problem and then work out the solution. Work backwards from the solution. So in software development, there is actually a name for this. If you just use it without thinking, it's called a cargo cult developer. Okay. Also, if you're using tool, you may need to develop new tools, especially if you are breaking new ground. Generally, you cannot, or it's very difficult for you to take existing tool, right, and create new stuff, break new ground, new technologies, right? So if you look over the last 5-7 years, right, you notice that there's this whole new paradigm of deploying to the cloud. And you notice that when deploying to the cloud, there's this whole suite of new tools, right? So these tools didn't exist prior to this new platform, right? So sometimes when you're doing new things, especially if you want to do new things, sometimes breaking away from the old tool, or using the old, adapting and using the old tool, is one way to go. Okay. The third pattern. Okay, so give you a few seconds to figure out what is the third pattern. Okay, so the third pattern is the third habit is to keep your solutions simple. Tony Hawk says that there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. Okay, so when we are building something, strive to make your solution, your product, simple, because when you got something that's simple, then it is easy to understand, easy for you to understand, easy for you to explain to somebody else. And if you have to document it, and most of the time it's easy to document. You don't have to write so much. You don't have to have tons of documents just to explain something. And it's easy to maintain because you can reason it very easily. And more importantly, it's easy to pick it up again. It happens all the time. You finish a project, 6 months later, your customer asks for a bug. Maybe there's a bug fix, or maybe there's a new feature that that your boss wants you to implement. So then if it's easy, then it's very easy for you to pick it up again. Okay, so simple doesn't mean simplistic. Okay, so those two are not equal. Okay, Tetris is a simple game, right? Tic-tac-toe is a simplistic game. Okay, so when you build, what is actually is simple. It's actually very difficult to define, and it can only be defined or talk about in the context of your domain. In my previous job, what I do is this: I work with a lot of software vendors, and one of the things that I help them to do is I help them to design frameworks and APIs. So I spend a lot of time in helping them to do that, right? And one of the tenet, or one of the guiding principle that I use for designing APIs and for building frameworks is this: the solution, the API that I design should allow new users to use it easily, and yet at the same time it shouldn't limit advanced user from doing clever things with it. So this is a very, very difficult way to design. Okay, and it takes a lot of trial and error, because it's very easy to design an API for just somebody to easy to use it. Lots of defaults, right? Lots of options, right? So if you do that, then you lock out a whole bunch of very advanced users, because the advanced users cannot use this API. Or if you make them so complicated, right? So much bells and whistles, so much knobs to tweak, that you cut off, all the new users from ever adopting it. Okay, so one of the key, if you want to learn something that's really, really powerful, look at the Express API. The Express API, personally, I think is like one of the simplest and the most powerful API, right? It allows you to do anything, right, without compromising its API. All you have to do is there's this thing called a middleware, and every request that comes through goes through this middleware. And what you do with it is entirely up to you. And that's the entire API. Okay, so it's very, very simple. So go and have a look at the API and look at how it is designed. So one of the things, so another tool that I like to use is this, because remember I'm developing APIs and frameworks. One of the things I like to play is board games, right? So when you buy board games, you have rules, right? And some board games are more complex than others because the rule book is really thick. Some board games, you got 2 or 3 pages. Some board games, you've got like 40, 50 over pages of rules. Okay, so you have rules. So you can either have really simple rule, you can have simple rules or complex rules. I'm just simplifying this, but I'm just saying this too, right? And then once you learn the rules, right, when you play, you can get really simple behavior in the game. When you play, the gameplay is really simple or very, very complex, gameplay, right? So obviously, if you got simple rule, you will expect simple behavior, like tic-tac-toe, right? Just find a line, just make a cross, so that you can draw a line across them, right? Right. So, or if you got complex rules, then you do not expect the behavior to be simple, because after you've read 50 pages of the manual, right? And then the gameplay is so simple, it's no fun, right? Same with computer games, right? If you're playing like RPG, you got player stats, all sorts of different stats, but then there's very little you can do with the stats, right? So then the behavior is very simple, right? Then you lose interest in it, right? So what's the point of having all that, really complex stat, right? Really complex magic system, and you cannot use it effectively, right? Of course, when you got complex rules, you expect complex behavior. The key thing is this: you should have simple rules that allows you complex behavior. So in other words, it's really simple to use, but you can build really, really complex. You can have really, really interesting gameplay of it. This is what Express API is. It is a set of very, very simple API rules, right? But you can do very, very complex things with it. Okay, so this is a chart that I like to use. Okay, so the fourth habit. Okay, so what's the fourth habit? Okay, practice. Fred Brooks, the author of The Mythical Man, once says, 9 women cannot make a baby in 1 month. Okay, so as software developers, it is a growing process. Okay, so software developers, they grow, right? So it's like learning to play a musical instrument. You cannot, like if you play the guitar, you cannot expect it to play, learn in 1 day. Even if you are musically talented, it takes time. It's a process. So being a software developer or learning or growing as a software developer is a process, right? You get better by practicing, practice, and you broaden the range of your repertoire. So for example, like, I still practice doing software development today. Most of my weekend, like from 9, to about 3 or 4 in the afternoon, during the weekend, I would write something. I would just write something. Sometimes just write something to throw it away, but just to practice. Okay. So very important, when you practice, you have to set aside time for it. You have to make it. You have to intentionally set aside time. Otherwise, you will never do it. Okay, right? So it's like, if you're going to learn to play the piano, right? You cannot just go to your music school, just learn there for 1 hour, come back and never practice, and don't practice and assume that you're going to be good at it. Okay, that will never happen, right? So same with software development. So what I'm saying is this: if you want to be, so if you take software development as a job, then working in your company and writing software in a company is enough for you. But if you want to grow as a software developer, then writing software during working hours with your job is not enough. Okay, you need additional time for practice. Okay, so what you need to do is this: you need to widen your experience. Work pro bono. That's what I do. Sometimes I would offer my help to my friends in startup, write something for them. Okay, so you help make them successful, right? Contribute to open source, right? So if you're in if you're in JavaScript, there's a lot of open source projects everywhere. Fix bugs. Okay, fix open source bugs, right? If you want to learn something, fix bugs. There are no better way to learn programming, to learn about a language than fixing bugs. Okay, try out new things. So if you're really bored, if you do Java, day in day out, and you're really sick about it, you do like Spring, right? You're sick about it. Try something new, right? Try game programming on things like Pico 8, which is like a fantasy console, or TIC-80. Do something new. The idea here is to keep your programming skills sharp and broaden your scope, right? Don't just start a Git repo, read the source. Okay, that will allow you to learn more things from it. Okay, practice and repeat. Even if you have written a program before, or when you're practicing, like you've written before, my suggestion is to write it again. Right? It's like playing scales. If you have learned musical instruments, one of the things they do is they play scales, right? C, C major, right? G, whatever, right? Just play scales. So why do they play scales? They play scales because it's to build confidence. If you're playing piano, confidence in hitting the correct key, or you're playing classical guitar, right? Hitting the correct note. Moving when you're moving your fingers, right? Moving to the correct fret. Okay. The other thing about practice is that it gives you time to experiment and explore the library that you are using. Unlike working, when you're writing a program and when there's a deadline and you want to do something, like when you want to make a HTTP call, you don't really have time to explore. You just find the first API that works and use that, right? But if you are offline, if you're at home and you're practicing, then that will give you a lot of time to explore some of these other alternatives to this one API. Okay, and another thing that I like to do is when I'm practicing, I try not to use the autocomplete, the autocomplete editor, because those things are really smart, right? They look at the context of the program you're trying to write and suggest the correct API. So if your objective is to learn, then you should ignore that, right, and explore other options. Okay. So generally, I like to do is that even if it's something as mundane as a to-do list, I try to write it again over and over again. So the challenge obviously here is how many ways can you write a to-do list? Well, surprisingly, there's quite a lot of ways. So I use Angular a lot. So you can write the to-do list using Angular only, right? And then using Angular with NGRX, using Angular with IndexedDB database, store the data in IndexedDB, write it together with a Node.js where you persist the data backend, write it as a pre-rendered application, write it as Angular Universal, right? Or change the backend from Node.js to Go. There are so many ways to write it. And then, today, if you just write the application, it's not enough. You need to also deploy it. So combine that with the deployment. There is like a CI/CD. So write a CI/CD. It's very simple today. If you store your code in GitHub, there is this GitOps, right? There's this whole CI/CD. They call it GitHub Actions. So there's this GitHub Actions. Write your CI/CD there. Deployment. Try it out, right? Build, test, deploy. So those are all these different ways that you can practice. You don't just have to stick with like just a plain old to do, right? Just let your imagination run. If you really run out of ideas, I think to-do list is a really good application because it's got front end, it's got back end, it's got persistence, it's got all sorts of things. But if you really run out of ideas, try writing extensions and plugins. For example, if today the Visual Studio Code is the editor of the month, is the flavor of the month, right? So you want to learn more about it, write a plugin for Visual Studio Code. If you like using a particular tool, for example, like Caddy Web Server. For example, I like using Caddy Web Server, and I find that it doesn't have an open API and enforcer, so I wrote one for it, right? Or another example, if you're using Terraform and you want to know how Terraform works, write a Terraform provider. That's how you learn how it works, right? When you're writing plugins and extensions, you are basically integrating with the software. So through that, you can learn different programming styles, something other than yours, right? So it forces you to understand the piece of software that you're integrating with. And this is very important. So this is growth for you. So you can use what you have learned in your future projects. When you're learning from YouTube, so YouTube is another way. If you run out of ideas, YouTube is another way. There's a lot of online course on YouTube, and you can get a lot of ideas from there, especially if you're doing web. Maximize your learning, right? A lot of times when you learn from YouTube, or you buy a course, or you take a course either in Coursera or Udemy or what have you, right? Sometimes they give you this this starter kit, right, that you work from, right? So generally what I do is that I don't use a starter kit. I will code my starter kit from ground up. Okay, and generally whatever they're doing, I will do something different. So when I'm adapting what I'm doing to the lesson. It takes longer, right? It takes longer, but ultimately what you're trying to do is that if you're trying to learn, then if you're trying to adapt what they are teaching to something that you are doing, then you are actually going to absorb and internalize more of the lesson. Okay. Another thing to do is that if you want to practice, is give feedback. On YouTube. Give comments, give feedback comments, right? What about if you do this, or can I try this, right? Blog or publish publish on Medium or publish on YouTube. Okay. So the fifth habit. Okay. Learn to debug. Each problem that I solve become a rule which serve afterwards to solve other problems. Okay. Descartes, he's a philosopher, French philosopher. Okay. So debugging is very important. Bugs come and go, but your debugging skill accumulates. Okay. So personally for me, I would, every time when there's a chance to debug, I would jump at a chance to debug. The debugging process is more, for me, the debugging process is more important than the bug. Okay. It allows me to gain speed, understanding my code, understanding other people's code, and by that, I get better at being a software developer. As a lecturer, as an instructor, we run quite a lot of programming classes. You'll be surprised, some of the most fundamental problems that the student makes, right? So sometimes you think that the easier the program it is, the easier it is to debug. That's not the case. A lot of times I find that the easier the program it is, the harder it is to debug. The reason is because I assume that it is simple. I assume certain things, and I don't see the bug. Whereas in really complex, in really complex program, I don't have that assumption, so it's easier for me to spot the bug. Okay, so this is one thing that I learned. So you also learn about yourself, about how to debug, right? As you debug more, you get intuition and insight into a piece of software. Okay, especially if it's something that you're working on. You have to understand what is, you have to, because in debugging, you have to understand your software, the behavior before you can debug. Learning to write program is very easy. Everybody can learn, right? Whether you write it correctly or incorrectly, that's another problem. But everybody can write a program. But fixing a program, debugging, right, is something that you have to do it correctly, right? Because otherwise the bug will never get fixed. Okay. So what are some good tools to debug, to use? Okay, a lot of you, I know, you use Visual Studio Code or IntelliJ or Eclipse. My editor is actually Vim. I use Vim simply because I work in Linux a lot, and and sometimes when you SSH into a VM, all you get is a VI editor, right? So I use Vim, and to read code I use CText, or if you read C code, there's something called CScope to read. So Vim and CText is enough for me, right? Of course, when you debug, a lot of people use debugger. If you've got IDE integrated, fine. They've got a debugging, they've got debugging environment. You can do watch. You can do, stack trace, etc. Because I'm using Vim, so I use printf a lot, or use print line statements a lot. And the thing about, people say, you shouldn't use printline statement, and I sort of agree with that. But because I'm using Vim, so I have to use printline because I don't have an integrated debugger. But using printline actually really helps me, because when you're using printline, you don't just simply print anything. Because if you simply print anything, then you get too much information and you cannot find the bug, right? So you have to figure out what to print, what are the relevant things to print. So printf is good if you know how to use it, and it's very, very powerful. It's really simple. Okay, when you're debugging, collect information. That's the most important, and observe the behavior, because bugs is about erroneous behavior. Observe the behavior, right? Sometimes in really, really complex environment, you need to isolate the code. In other words, because debugging, generally the way you debug is this: you observe a behavior, error behavior, you change, you do some debugging, you compile, then you observe, oh, the behavior is not correct, so the debug cycle sometimes can be quite long, especially when you're debugging applications like web applications, right? So sometimes it's easier just to pull out the chunk of code where you think the error is and make it into a standalone program with a main, and then test the piece of code. Lay the foundation. So, and when you write program, you know that you're going to have bug. So lay the foundation for debugging, right? Add things like logging, like probes, dumping stack traces. Okay. Be persistent when you debug. Try to find the bug yourself, even if it takes you hours. And this is what something that I would never ask somebody to help. The reason is because, like I said, I value the debugging process more than the bug. Because as you are debugging over hours, you are trying different ways to find out the bug, to try and discover the bug, right? So you are actually thinking all the time, constantly all the time. So by doing that, right, you're actually building resources to help you with the current and future bugs. Your skill in helping you in current and future bugs, right? So sometimes, right, when I'm teaching and then my students say there's a problem, I say, oh, the problem is here, right? Well, then they say, you can debug so fast. Yeah, the reason why I can debug so fast is because I spent 3 hours previous day trying to debug this. Okay, so you have to spend time, a lot of time debugging. The other thing about debugging is that debugging actually gives you confidence, because if you can solve something, then you can certainly write something, or you can certainly teach something, because you understood how the software works. If you must ask for help, Stack Overflow is the best place. The reason is because there are many forums, that you can ask for help. But and why I think Stack Overflow is the best place to ask for help is because you have to really think about what you are going to ask. You cannot just ask the question, because if you just ask any silly question, you get voted down. The question that you have, the bug that you have, will get voted down, right? So it's very, very important that you think about the bug. Okay, the sixth habit. Okay, rest and exercise. There is no vaccine for broken legs. Sacha Baron Cohen. This is Ali G or Borat. Okay, programming is a very, very demanding job, both mentally and physically. Okay, it's a very unnatural thing to sit on a desk, stare at the screen and type without moving anything, only your fingers. So you have to be fit, right? So better concentration. Generally, I find that as I get older, my concentration isn't there. So you need to exercise to have better concentration, because you are fitter. Okay. So when I'm stuck with a bug, right? Generally, I try to do something relaxing, right? So I'll do some physical exercise. I'll do jogging or swimming, right? Never ever go and play a computer game. So try not to do anything. I try not to do anything that requires me to look at a screen, like playing computer games, right? Or play a musical instrument. So I generally go and play the guitar, right? Another thing about it is that so when I'm stuck or when I have a problem to solve, when I try to I go and do exercise, physical exercise, and when I'm doing exercise like physical jogging, for example, or swimming, I do not listen to music. I listen to the traffic instead. Okay, the reason is because if you have music stuck in your ears, right, then you don't have time to relax, right? And one of the things that I like to do is this: when I'm jogging, I like to think about the problem. Okay, I like to think about the problem. And very often I find that, for whatever reason, I don't know, maybe when you're jogging, there's more blood going to your brain or whatever. Generally, I would try to I would get a solution to the problem, or a partial solution, or some insights into the problem. So if you haven't tried this, try it sometimes, right? Just go jogging. Don't bring your phone. Okay, don't bring your phone. Don't have headphones. Just jog, right? The other thing about programming is this: make yourself comfortable. I cannot stress this enough. Get a good keyboard. Most of the time, when you buy a computer, they will give you this keyboard. That keyboard is actually not very good. It's not very accurate. So invest in a good keyboard. Invest in a good keyboard, because a good keyboard, really allows you to type more accurately, right? You can build up your typing skills. Okay. So the last habit. Okay, anybody guess? Is this? Okay. Learn from your projects. Leo Tolstoy in Anna Karenina, the book Anna Karenina says, first line, classic line, says, all happy families are alike. Each unhappy family is unhappy in its own way. What it's saying is this: all happy families are happy for the same reason, right? Every unhappy family is unhappy for its own very unique reason. So in the same way, all your projects that are successful for the same reasons, right? Maybe you're prepared for it. Okay, maybe you got a correct team member. You understood the problem, right? All the projects that fail for their own particular reason, right? You don't have enough time. For example, you commit yourself to too much things, too much features, or you commit yourself to something that you do not know. You don't have know-how, right? The project was badly managed, or the requirements keep on changing, right? So look at your past project, what has worked and what hasn't worked, right? And try to figure out, those things that have worked, what are they? What are the reasons they have worked, right? And try to have the same condition again going forward on new projects. Okay, what hasn't worked? For example, like my last time when I do Angular, I use NGRX. It was a disaster. Why? The reason was because it was a very simple application, and NGRX was way too complex for it. I should have just used something. I just used a simple service to hold my data. Okay, anticipate some of the skills that you will be needing. So like I said, I do not like to learn on the job, especially with API, because then you're forced to use the first, as generally with time constraint, you're forced to use the first uh, the first solution that you come across, right? So you should have a variety of solutions. You should have options when you are forced into a choice. You should have options. Okay, look at job postings, not because you want to change job, but to see what are the roles and what are these roles and what are they asking for the roles. So generally, the way I look at it is this. So generally, when you look at a job, right, there are two sections, right? One is a requirement, and there is like a good to have. Okay, so generally, what I'll do is I'll look at the good to have. It's good to have is what else are they needing? If somebody like look for a front of a full stack developer, right? So the requirements will be things like, you need to know like React, Angular, Java, whatever, right? So those are your bread and butter, your standard stuff. Look at the other stuff, the good to have. Okay, that is what is telling you. That's a direction that's heading, because sooner or later the good to have will be part of the requirement going forward. Okay, bookmark interesting articles. You don't have to read all of them. I've got a few websites that I go to, and I just browse them. Blogs are generally very good. Just browse them, look at the article. Interesting, I'll read. Sometimes if it's not so interesting, I think maybe I'm not interested in it now. Just bookmark them, keep them, have an idea of what they are, and bookmark them, so that in future when you do need them again, you know where to go and get it. Okay. Yeah. So that's generally my take on it. The 7 habits. First habit is to understand the problem. Second is to use the correct tool. The third is to keep your solution simple. Fourth, practice. Fifth, learn to debug. Six, exercise and rest. And 7, learn from your project. So that's the end of my presentation. Thank you very much.